Okay, I'd like to talk just a little bit about the mitigation, the tools, some of the different things that go along with the A2L refrigerants. So remember, in the A2Ls, we're typically talking about 454B and A32. So if you look at what I've got here kind of sitting on the table, I've got some of the equipment that could be A2L compatible, such as the DC vacuum pump and the DC recovery machine. What they're looking for is since A2L is flammable or mildly flammable, we don't want any equipment being used that's going to create sparks. So the DC type of recovery machine, the DC voltage type vacuum pumps, they don't create those sparks, or at least not as much, and they are rated more for the A2L. If you're in doubt, just look at the machine or ask the manufacturer if it's A2L rated. Both of these happen to be. Another thing with the A2L refrigerants is that the refrigerant tank has left-hand threads, and the recovery tank has left-hand threads. So you'll need a hose that has left-hand threads, or you'll need an adapter for yours. Meaning, when we say mildly flammable, what we're talking about is if we have a fire and A2L goes on, it will slightly burn, but the minute the fire goes out, the A2L goes out. So that's that's what we're talking about when we say mildly flammable. A2L, especially like 454B, very similar in pressures and temperature relationship to 410A. So the things that you're used to, the fixed orifices, the expansion valves, that stuff is all the same. Nothing's really changed. The charging procedures as far as pressures and temperatures are the same. It's not that big a deal. There's some specifications that come out with A2L we have to pay attention to. One of them being the contactors. So contactors in the condenser are all going to be sealed. A lot of contactors look sealed. That doesn't mean they're sealed. You have to make sure that they're A2L compatible. If you buy a new A2L condenser, it will have the compatible contactor in it. But the contactors are non-sparking type sealed contactors. ASHRAE, who we get a lot of our recommendations from as far as ductwork and safeties and all sorts of things, ASHRAE suggests that we use some sort of tool or device to verify that our gauges that we're using on A2L refrigerants are accurate. Minimum is that we follow the manufacturer's instructions on how to calibrate our gauges. If we want to have them calibrated or calibration checked, we can have them tested through a master gauge or a weighted gauge set or something similar to this, just to make sure that we're reading dead on. When we're looking at leak detection type devices, when we're looking at a leak detector such as this one here, we want to make sure we find a leak detector that's A2L rated. This one is, a lot of them are, but you got to make sure that it is. And then finally, we'll look into the mitigation board itself. And when we're looking at just this mock-up board that I have set up right here, what you're seeing is a standalone mitigation circuit here connected to a furnace control board, and then it's in between the thermostat. What's the matter? What's the matter? Okay, when we're looking at a mitigation control system, what we're looking at is a control board like we have right here, and it's going to connect between the thermostat and the furnace control. So in a typical installation without a mitigation control board, you have the thermostat talking directly to, say, the furnace circuit card. In this case, what we do is we put the mitigation control in between those two. So what happens is, if the mitigation board senses, if the sensor, which I don't have, but if a sensor senses a buildup of the R32 or 454B, what it's going to do, it's going to go into a mitigation action. And what that means is it's going to turn off your AC, possibly your heat, depending on how it's connected, but it's definitely going to turn on the indoor blower. So once it senses a buildup of these A2L refrigerants, it's going to turn things off, but it's going to turn on the fan. That's the dilution part, right? The indoor fan's going to run. It's going to blow that little bit of refrigerant around the house, and the volume of the house, the square footage turned into cubic footage of the house, is going to let that dilute. And what we're trying to do is make sure we don't build up any flammable contamination vapors, right? So you can see the contactor right now, this thermostat is actually calling for cool. But because we got this flash code going on here, this board is in mitigation right now. It's not allowing the contactor to run, so the compressor outside will be shut off. It is running the indoor blower. So this is what happens during mitigation. Indoor blower runs, outdoor unit shuts off, and then once it quits sensing the refrigerant, it's still going to run that fan for 5 more minutes. Okay, so let's take a look at the condenser and see some changes on the condenser. So the condenser itself, it's going to be labeled, of course. It's going to have labels all over it. Depending on the manufacturer, the labels are going to state that it does have a flammable refrigerant in it. It's going to have caps that are either colored, such as these, possibly tags and all sorts of things on here. They're usually going to be red, kind of letting you know, alerting you there's a flammable refrigerant in this. So that's going to be on the label. What we're going to do, if it's not already there, is we're going to add locking caps when we get done. That's part of the standards with this refrigerant, is to have locking caps. So if they're not there, you want to make sure you add locking caps when you get done. There'll be different labels on there. When it comes to the refrigerant can, it's got a red stripe on it. Typically, something with a red stripe means flammable. You're going to see that on the refrigerant can. The recovery tanks are also going to have a red stripe on them. Both of these tanks are going to be left-hand threads. The equipment itself is not going to be left-hand threads. It's the same. The recovery tank and the refrigerant tank will be left-hand threads. So you'll need the hose or you'll need an adapter. Now, the other thing, like I mentioned, was the contactor is going to be a sealed contactor. Also, inside the compressor compartment, some manufacturers are going to use a sheathing or a seal tight, some sort of material over the wiring to the compressor. Otherwise, the molded plug itself is pretty spark proof. So there's not really a lot going on in the condenser unit. When we get into the inside unit, the evaporator, the air handler, the furnace, whatever you happen to have, the coil. If you buy a standalone coil, the coil is going to come with the sensor. In this case, the mitigation sensor is right here. The coil typically comes, the manufacturer tells you exactly where to mount it. If it's not already mounted, they tell you where to mount the sensor. The sensor wire then gets routed over to the mitigation board. The mitigation board gets wired up to where it's basically, again, between the thermostat and the control board that's in there. In this case, electric air handler. So basically what happens, if we go into mitigation, it's going to turn on the fan. Now this red light here is wired up to the 24 volts of the fan. And I'm going to put this in mitigation and show you how it works. So I'll come over here and I'll put a little bit of a flammable refrigerant in the sensor area. And if you watch over there at the sensor, the mitigation board, you'll see it start to flash, and then you'll notice the red light come on. There you go. So within 30 seconds, it has to detect that refrigerant buildup at a concentration that's been deemed at a level we need to turn something on and dilute it. That's already pre-programmed into the sensor. You don't have to mess with that. It calibrates itself. It tests itself. If something goes bad with the sensor, it's going to go into mitigation. In this case, we can see it's in mitigation right now. The outside unit would be off. The indoor fan is going to run. Once it clears the sensor, which is probably already cleared, this is going to run this fan for 5 more minutes to keep moving this stuff around the home. That's why it makes it safe, because once it builds up a level here that hits a certain flammability limit, still well below the ignition level, but enough to say we need to turn on mitigation. It turns on that mitigation and it continues to run and disperses through the entire volume of the house. That'll stay on for 5 minutes. Once that 5 minutes passes, it resets itself automatically and turns back on. Just during that 5 minutes, you're not going to have AC. The other thing I want to point out was while it's in mitigation, you're going to get flash codes. And the mitigation board is going to tell you what those flash codes mean. The amount of flashes, mean it's in mitigation or it's in a waiting period or it's got a sensor failure or whatever might be going on is going to be shown by that flash code. The final thought I want to kind of give on this is the fact that when you're looking at the A2Ls, and we're looking over here, we've got the A2L chart, the PT chart, and we got the 410A right beside it. We can see the pressures are just a few pounds difference. It's very, very similar to the pressure temperature relationship we're already used to. So we have to just follow some safety practices, such as we would never put a torch on this system or on the dryer. We would never unsweat any components. We're going to cut components out. We're not going to unsweat them, right? We're also going to never cut into an A2L containing machine until we've completely recovered it. And then we're going to run nitrogen in it. We're going to purge it. And the manufacturers give us all these specs. You're going to purge it. You possibly will have to triple evacuate the system. But we're going to follow those tests, including what they call strength test, pressure testing, and vacuum testing. And those are all listed in ASHRAE as well. And the manufacturers spec that out, each one, slightly differently. Some of the pressure tests are as high as 600 pounds. You have to follow the manufacturer's directions on that. The goal here is to make sure that nothing's ever taken place where we're letting refrigerant stay in this system while we're brazing or cutting or any kind of sparks. So all these methods are just to keep things very safe for us and the homeowner.